Hello, I'm Professor John Gallagher, and welcome back to Raspberry Pi School. In this lesson, I'll demonstrate how you can perform a headless Raspberry Pi setup if you first need to get the MAC address, plus I'll show you how you can configure your Raspberry Pi for use on multiple Wi-Fi networks. Now, many educational institutions around the globe rely on the EduRoam network. If you visited a major university worldwide, chances are it's on EduRoam. This allows me to use my university ID and password to log onto Wi-Fi at just about any university I might visit. But if you're connecting devices like a Raspberry Pi, a smart speaker, or a video game console on a network like this, you either should not or cannot use your personal user ID and password to connect those kinds of Wi-Fi devices to the network. Now, if you're setting up a Raspberry Pi on a network like this, here's the conundrum. Most campuses do let you register consumer devices using what's called a MAC address. So this is usually done on a separate network outside of EduRoam at Boston College. This is done on a network called Boston College. But again, to run a device on that network, we need the MAC address. Now, the MAC address is not the same as an IP address. The MAC address is a unique and permanent address that comes with every network-capable device. Now, most devices have the MAC address on a sticker on the device itself. The problem with a Pi is you need to log into the Pi to get the MAC address. And if you're using the Pi remotely without connecting it directly to a keyboard or mouse, this is often called Headless Mode, and that's what my students are doing. They're logging onto their Pi over the Wi-Fi network from their laptops. Then you can't log in over the network to get the MAC address. So here's the solution that I'm having my students use and that I'll demonstrate in this video. We'll first install a fresh version of the Raspberry Pi operating system using the Pi Imager software, and we'll configure the Pi to use Wi-Fi when we've found the MAC address and we've registered that address and have had it approved on our network. I'll also show you how you can set up a Pi so that it can use multiple Wi-Fi networks. This is good if you're using a Pi, say, at school, but you also bring it home to use on your home Wi-Fi network. Then we'll use an Ethernet cable over USB to remotely connect the Pi so that we can get the MAC address using a utility called Ifconfig. I keep a bunch of these cables at the campus makerspace, outside my office, and I bring them to class. Then I'll quickly show my students where they can go to register their MAC address on campus. This is where you'd use your own MAC address approving procedure on your own organization's network. And then finally, we'll connect to the Pi over Wi-Fi and we'll see that everything works. In this tutorial, you'll see me copy and paste from a step-by-step guide I've created in a Google Doc, and you can find that at bit.ly/pi-on-campus-multiple-networks. All lowercase, and this will be especially useful for copying large blocks of text and commands used in this setup. First, we're going to install the Raspberry Pi OS on our micro SD card. So take your micro SD card. If you have something like this, it's the little card that we need. The big thing is an adapter for the card slot, so you can throw the big thing away. But for my students, please keep the container to hold the card. Now plug the card into your card reader. It should only go in one way, so if it looks like it's crooked or it's getting stuck, just flip it over. Some card readers require you to push the card in. You'll hear a little snap until it's engaged, and then when you remove the card later on, you have to push it again and you'll see the card pop out. Then plug the card reader into your computer, and you should see the card reader mounted on your desktop. Next up, open a browser and get the latest version of the Raspberry Pi OS installer program. You'll find this at raspberrypi.com. Click the Software tab at the top. Find the download button for your computer's operating system. I'm using a Mac, so the website recognizes this. My computer asks me where I want to save this download. I'm going to save mine to the desktop. If your browser doesn't ask you a save location, then it's probably saving this in your Downloads folder. Then when the file's downloaded, find it, open it up, and follow the instructions just as you would when installing any other program on your computer. Now I'm on a Mac, so I'm going to drag the Imager icon to the Applications folder. I have a copy already, so I'll just write over the old one with this new one. And once you've installed the Imager program, you can delete the file that you've just downloaded. As a bonus tip for Mac users, installer programs often mount meaningless volumes on your Mac, so you can just find the Raspberry Pi Imager volume on the left-hand side of your Finder and click the eject button so that you're not confused by having this bogus volume appear on your computer. Now I'm going to open my Applications folder, find and open the Raspberry Pi Imager application that I just installed. A security warning may ask if you're sure you want to open this file, select Open, and then you should see a screen that looks something like this. First, let's select our version of the Raspberry Pi operating system. You can click the Choose OS button, and it's okay to select the top option, which should be the recommended option. Next, select the Choose Storage button. This is where we select the SD card where we want to install the operating system. So be sure you select the correct volume. I'm using a 32 gig card. That's what I installed using my card reader. So that's the one that's up here. It's just under 32 gig in size. I do not want to select the 2 terabyte drive down below it. Now, you probably don't have something like that on your computer, but that's my external hard drive. And installation will format over any volume. So be sure that you're selecting your SD card and not a hard drive. Now, if you're following along our step-by-step Google Doc, the next step says to click the gear icon in the lower right that brings up the advanced configuration menu. And for my students setting up their Pis on campus, follow these steps exactly. So first, click the checkbox next to Set Hostname. The hostname is the name of your Raspberry Pi, so give it a unique hostname that you will remember. Others might see your hostname in a network scan, and you'll have to share it with the university, so please make sure that your hostname is suitable for public viewing. Now I'm going to name this Pi JG-PhysComp for physical computing, although you can use your last name if that's unique enough. 2 initials might not be unique enough. You can choose whatever you'd like that's unique, just make sure that you remember it. Then click the Enable SSH checkbox. This will let us use a terminal program on our laptop and then use the SSH command to remotely connect to our Pi. Then scroll down and select Set Username and Password. Keep the username as Pi, all lowercase. That's what we're going to be using throughout our tutorial videos. But enter a unique password and be sure that you remember your password. Pro tip, make it a priority to get a password manager and keep your Pi names and passwords in there. I use 1Password. I have no affiliation with this company, but it lets me access my passwords from my desktop, any browser, or my smartphone. You can do a search online to find which password managers are best for you. Good password hygiene has saved my bacon on many an occasion. Now, as strange as it might sound, do not click Configure Wi-Fi. We're going to need to do this separately through the terminal program, since the configuration that we need to set up isn't available from this screen. Now, I'm also going to show you how you configure multiple Wi-Fi networks when we get to the Wi-Fi setup portion, so that's coming. So do not click Configure Wi-Fi, but do click Local Setting. Make sure that the time zone reflects the time zone that you're in. I'm in Boston, which shares a time zone with New York City, so this is okay. And make sure that your keyboard selection is for the country that matches to the keyboard that you're using. I bought my Mac in the United States, so it has a US keyboard. We'll leave Skip First Run Wizard unchecked. Leave all of these other checkboxes selected, then click Save and Write. You'll probably see a warning that says you're about to erase the volume that you've selected, but since I selected my 32GB SD card, this is exactly what I want to do, so I'll select Yes. You may be asked for your laptop or computer password to approve that you're about to overwrite a volume connected to the computer. I'll enter my Mac's password and select OK. And then you'll see a progress bar scroll by, then a verification progress bar. These steps will take several minutes, so feel free to grab a beverage, check Twitter, Slack, your email messages. And then when things are done, you'll see a message that says that you can now remove your SD card from the reader. Now click Continue, but we don't want to remove our SD card from the reader. We're still going to work with the card in the card reader, but the installer program has unmounted the card reader. So you won't see the card volume on your desktop anymore. But if you physically unplug your card reader from your USB port and then plug it back in, you should see the card show up again. If you're using a card reader that's in your laptop or computer, just pop the SD card out and then pop it back in. And if everything worked okay, you should see a volume named Boot mounted on your computer. Now comes the part where we need to use a terminal program. So Mac users have a terminal program on their computer already. Windows users, you need to download a program like Putty for free online. Just search online, download and install it just like you would any other program, then run Putty. Mac users, you can find the terminal program by opening Spotlight by holding down the Command key and pressing space, then typing in the word terminal and pressing return, and the terminal program should launch. And for both Windows and Mac users, we can hop back over to our installation Google Doc, and the next command that we want is this one here that says tut/V volume/boot/SSH. Now select and copy this command. This is going to create an SSH file, which is needed so that we can use the SSH command to remotely connect to our Raspberry Pi. This is a bit of security to keep your Pi secure. Raspberry Pis don't automatically allow remote login by default, so you will need to do this to access your Pi over the Wi-Fi network using SSH. Then back in the terminal program, paste this in at the prompt and press return. By the way, if you're new to the Mac, I'm switching between programs using Command and the Tab key. That's a useful shortcut to memorize if you don't know it already. I think Windows has a similar shortcut with Alt-Tab. Then this next command we want is this one here that begins with nano. Now nano is a text editor program that we're going to use to create a file on our boot volume. That's our SD card, and the file that we need to create needs to be called wpa_supplicant.conf. So I'm going to highlight this command, copy it, then Command Tab over to the terminal program, paste this in at the prompt and press the return key, and the screen clears and I'm now in Nano. Now here's where we enter file configuration information needed to connect to Wi-Fi. And back in our Google Doc, I've got text that my students can use to copy and paste to set them up on the Boston College network as well as their own home network. Why don't you highlight and copy this text that begins with the word country and ends with this second closing curly brace here, then return to the terminal program and paste it into Nano. Now, Nano doesn't use the mouse, so if you want to edit any of this text, be sure you use your arrow keys to move your cursor around and use the delete key to remove any text that you want to get rid of. Now, if you're not on the Boston College network, you obviously want to enter the name of the network that you're using. Now, even though Boston College is on the EduRoam network, all of the approved consumer devices that are used on campus, like smart speakers, game consoles, and Raspberry Pis, are on a network called Boston College, spelled exactly as you see it here. Notice there's no password here either. Now, this network can allow devices to be approved via what's called a MAC address. That's a unique and unchanging permanent address that's associated with each device. So if that's what your network uses, you likely require a line in here which says key_MGMT equals in all caps none. So if you're not at Boston College, be sure to check with your network support people or your help desk if it's not clear what network name to use or how to set up consumer devices on that network. Now you can also see that I've got two networks in here. The first one is my university network. The second one inside the set of curly braces ends in location 2. So if the Boston College network isn't found, my Raspberry Pi is going to look for this second network, location 2, instead. Now if you want to set up your Pi on your home Wi-Fi network or any other Wi-Fi network that requires a user ID and password, you can enter the name of the network between quotes after SSID. This should be spelled and capitalized exactly as it appears in the list of Wi-Fi networks that you would see when connecting to your Wi-Fi network, and your password goes in between the double quotes below this, replacing my network password. So if you add your home network here, your Pi will first look for the first network in the list, the Boston College network, and then if it can't find this, it will look for your home network. Now you can add even more networks. Just copy this block of text that starts with network and ends with a closing curly brace. Then just update the SSID with the new network name, the PSK field with your new password, and also make sure that you increase the location number for each new network that you add. And by the way, if you're only going to be using one network, then it's totally okay to get rid of this whole block of second network from network through the second closing curly. So once you've got this all set up, again, make sure that you haven't accidentally deleted any of the double quotation marks or the curly braces, because if you do, your network connection will not work. Then to save this file, type Control-X. When asked if you want to save the modified buffer, select Y for yes. Then when you see the file name, just press return. It's going to save it with the proper file name, and we should be returned to the prompt with your Wi-Fi properly configured. Now, since we're on a network that needs our Raspberry Pi's MAC address, we're going to connect our Pi to our computer using an Ethernet cable. We'll log into the Raspberry Pi, and we'll use the Ifconfig command at the prompt through the terminal to get the MAC address. Then we can copy down that MAC address, submit this address through our campus approval process, just like we would if we were using a game console or smart speaker. At Boston College, this is done through the website helix.bc.edu. Again, check with your network administrator to see what the procedure is on your campus, and then our Pi should be available for use over Wi-Fi. So to get the Raspberry Pi's MAC address, I can quit the terminal program and the Raspberry Pi imager if you still have that up, and I'm going to right-click on the boot volume and select Eject. The volume disappears from the desktop. Then you can unplug your card reader. We won't need that anymore. And I'll take my SD card out of the card reader, and I'll slide it into the slot on the bottom of the Raspberry Pi. Again, it only goes in one way. The metal teeth should be facing in, and if it's not going in straight, just flip the card over and try the other way. Now I have a small Ethernet cable connected to two USB adapters. So plug one end into the USB slot on your Pi, and again, these only go in one way. Then I'll plug the other end into my Mac. I need to use an adapter since my Mac has a USB-C connection. And again, for my students, I've got this equipment in the makerspace on campus as well as outside of my office. So just stop by either location to use either of these if you don't have your own gear. and then we're ready to power up our Pi. We can do that through the micro USB port that's on the Pi. For my students, you can use the same USB cable that you used with your Circuit Playground and your Arduino boards. Again, this is another connection port that only goes in one way, so check the cable and the port before trying to force this connector in. And then my Pi and my Ethernet cable should be plugged into my laptop. You should see a light flash intermittently on your Pi to indicate that yes, the Pi is getting power, and we're ready to log into our Pi. Now I've created a Google Doc, and this is where I'm going to save the name of my Raspberry Pi, and I'm also going to paste in my MAC address underneath here so that I've got a copy of that. So now let's log into the Pi so we can get the MAC address. Then we can head back to our instructions document and scroll down and find the text that shows the command ssh-keygen --r hostname. Now copy this first part, but instead of hostname, we're going to be putting in the name of your Raspberry Pi. So we're going to paste this into the terminal program. Windows users open up PuTTY. Mac users, you can press Command Space to open Spotlight, then type terminal and press return. Now paste the command into the prompt, but don't press return yet. What we want to do is after the space, we want to enter our host name, which should be the host name that you gave your Pi earlier when you were configuring things in the Pi installer program. So my name was jg-physcomp. Add .local at the end of this. There's no space in between the host name and the .local. Then press return. Now you might get a message that says this wasn't found. That's totally fine. The command that we just entered is useful if you're setting up a Pi using a name that you've used previously, so it's good to have this in your list of commands to perform, and it doesn't hurt anything if we get the message that we've just seen. Now the next step is to log into your Pi using the SSH command, so we're going to connect to our Pi. To do this, at the prompt enter SSH, a space, then Pi, which is our username, the @ symbol, and the name of your Raspberry Pi, the host name, and .local. So make sure it shows up just as you see it here, and then I'm going to press return. You may or may not see this message about the authenticity of the device being established. If you do get this message, just enter yes and press return. If you don't see it, don't worry about it. Then when asked for your Pi's password, this should be the password that you entered when configuring your Raspberry Pi using the Pi Imager program. So that was the password that you entered there. This password won't show up on screen when you type it. It's masked, but it is being entered. And when you've entered it, press return. If you enter the password properly, you should be returned to the prompt that looks like this. It says Pi @ and then your Pi's host name, showing that yes, you have in fact logged into your Raspberry Pi. Congratulations! Next up, we enter the Ifconfig command at the prompt, and that'll give us a whole lot of text that we can ignore, but it will show the MAC address, which is what we need to register our device for use on the campus Wi-Fi network. So at the prompt, type in ifconfig, one word, all lowercase, and press return. And you should see a lot of stuff. Again, we're going to ignore this all, except for this line in the section that begins with WLAN. You should see this line here that starts with Ether, and take a look. You should find a list of 6 alphanumeric digits separated by colons, so copy this whole block of values. For me, it's this block B8 through CC. Yours will look different, but you should still have a set of 6 2-digit alphanumeric characters separated by colons. Copy this. Now I'm going to paste this back into my Google Doc that I created before so that I've got a copy of this in case I lose it on my clipboard, and I'm going to use this MAC address to register my Pi on the campus network. Now, this step is going to be specific for my university, Boston College. At Boston College, our students register their consumer devices like Raspberry Pis, but also game consoles and smart speakers at a website called helix.bc.edu. So for my students, go to this site. Students on other campuses, check with your help desk to figure out how you register such devices. So when my students visit this webpage, they're going to see a device registration link at the bottom. Click that link. For MAC address, paste in your MAC address that you just copied. The device name should be the same as your Pi's host name. For device type, you can select consumer Wi-Fi device. For notes, put in your name, your Boston College user ID, not your password, and say that this is a Raspberry Pi used in the physical computing course. Then click the checkbox that says that you are the owner of the device and click on Create. Now you should get a message that says the device was properly created on the network. If for some reason you get a message that says the MAC address is already in use, then check the step-by-step instruction tutorial Word document you are copying and pasting from before. I'll put in some special notes with additional instructions in there, but you would only get this message if you're using a Raspberry Pi that had already been used a previous semester and already had its MAC address registered on the Boston College network. So now we're ready to head back to the terminal, and whenever you want to power down your Raspberry Pi, you should type in this command, sudo halt. Sudo, or sometimes called sudo, is a command that we use to provide access to the more dangerous commands that you wouldn't want to give to, say, a guest user that had access to your device. So sudo stands for substitute user or super user, with do meaning do this command. So this should halt our Pi. When you look at your Pi, wait about 5 seconds to make sure that the lights on the Pi have stopped flashing, and then you can unplug the Pi. Then I'm going to unplug the Ethernet cable from my Pi and from my Mac. I don't want to connect over Ethernet. I want to use Wi-Fi. I'm going to plug my Pi back in. It usually takes about 20 seconds for the Pi to boot. And then we're going to enter this ssh keygen.r command that we entered before. So find and copy this command, return to the terminal, paste it in, but don't press return yet, because remember, after the space, you have to enter hostname.local. Now, you may or may not get this message about the original name being retained in a file ending in .old. Either way, don't worry about it. And so now, very important, everything we did up to now was setup, but when you want to log into your Raspberry Pi over Wi-Fi, each time this is what you do. You open the terminal program, and at the prompt you enter this command, ssh space pi at, and then your Pi's host name, and press return. Now, for my Boston College students on the Boston College network, you shouldn't need to add .local to the end of the host name. But if you're working from home on your home Wi-Fi network, then you probably do need to add .local at the end. But this is the command that you're going to enter each time you want to log into your Raspberry Pi over Wi-Fi. If for some reason you try to log in this way and it doesn't work, then try either adding .local if you weren't using .local, or removing .local if you were adding it before. But if everything was set up properly, this should log you into your Raspberry Pi. So again, remember, when you want to get into your Pi, open the terminal program, ssh space pi at hostname. You shouldn't need .local on campus. You probably need it on your home network, and that should get you into your Pi. Now, if your Pi is being recognized on the network, you may or may not get this message about the fingerprint. If you do, just enter yes and press return. If you don't worry about it, but then you should be asked for your password. So if your Pi is being recognized and you entered your SSH command properly, enter your password. Remember, it's not going to show up when you type it. Press return, and if you enter the password properly and everything goes right, you should be at a prompt that says Pi at and your Raspberry Pi's host name. And if so, congratulations! Your Pi is ready for use on the Wi-Fi network. And just a quick introduction to check things out, if I type in the ls command at this point and press return, that'll get a list of all of the files that are in the current directory. I can see a bunch of files and folders that are on my Pi. We'll learn more about this in future videos, but feel good about your skills and head on to the next video where you'll learn to update software on your Pi and prepare it for use with CircuitPython. And just a reminder, when you're done using your Pi, it's always a good idea to type in sudo halt, press return, and then wait about 5 seconds before unplugging your Pi. So now you're proficient in Raspberry Pi setup on a Wi-Fi network. That is another skill in your bag of technical tricks. Nice work!